Yes. So the title of this talk is Make Computing Personal Again, Lxroot, a safe and lightweight alternative to chroot, Docker, and floppy disks too. My name is Park Bostrom, and I am the author of Lxroot. Here's an overview of what we're going to talk about. Motivation and about Lxroot. Running Arch Linux, Chromium, Steam, and games inside Lxroot. Limitations and ecosystem compatibility. Personal again and platform diversity. Overlaying directories, command line interface, and VLAN. And then a conclusion. So motivation. For years I wondered, why isn't there a version of chroot for non-root users? Then I learned about unprivileged Linux namespaces. It seemed it would be possible to use unprivileged Linux namespaces to write the non-root version of chroot that I had long wanted. So I did. Lxroot is 1,300 lines of C++ code with almost no dependencies that compiles to 164 kilobyte statically linked executable, that runs safely without root access, and that requires kernel support for unprivileged namespaces. In addition to chrooting, Lxroot can make select subdirectories read-only, overlay, i.e. bind mount multiple directories to dynamically compose a chroot environment, and optionally block all network access. Also, Lxroot environments are nestable. You can run Lxroot inside Lxroot. So let's look at running Arch Linux and the Chromium browser inside of Lxroot. To do this, we're going to download, extract, configure, and run. We cd to our home directory, and we download the official Arch Linux Bootstrap tarball, which contains a chroot environment. We make a directory called Arch, and we extract the tarball into that Arch directory. Then we do some configuration. We copy in resolve.conf so that DNS will work. We make a home directory for our non-root user, and we copy the X-authority file in so that Chromium will be able to access the X11 display. Then we run Lxroot, pointed at the Arch directory. We ask for network access. We are going to run a package manager, so I use this simulated root option. I don't have time to explain it in this talk, but it's useful with package managers. And we run pacman to install Chromium. This will install Chromium in the chroot environment that we just extracted. And then we run Lxroot again, pointed at the Arch directory again. We want network access. We want to share the Xorg display and share Pulse Audio. And we run Chromium, and Chromium should run. Let's move on. Oh, but one more thing. I'm working on automating those configuration steps. So in the future, Lxroot may help you do those, so you may not need to type the configuration steps in. We'll talk about running Steam and some games inside of Lxroot. I started with an Ubuntu Linux host. I used Lxroot with a separate Ubuntu userland. And then in that, I ran apt to install Steam. Steam ran, and I used Steam to install a Windows game. I installed Creeper World 2, and much to my surprise, it actually ran and was playable. However, it's a little bit difficult to use apt inside of Lxroot, so I was curious to see if I could use a different userland. So I tried again with a void Linux userland. I ran xbps to install Steam. That worked, and I was able to install Creeper World 2. However, it failed to run. I was curious to know if that was because of Lxroot or something else, so I set up a second system with void Linux and used xbps to install Steam, installed Creeper World 2, and it failed to run with exactly the same error message as inside of Lxroot. So obviously the next step would be to use Lxroot on the void Linux host, and with an Ubuntu userland, use apt to install Steam and install Creeper World 2 again. But I haven't done this because it's difficult to use apt inside of Lxroot. Let's talk about why it's difficult to use apt inside of Lxroot. Limitations and ecosystem compatibility. So Lxroot is safe and lightweight due to its use of unprivileged Linux namespaces. In an unprivileged Linux namespace, the SUID bit is ignored. Changing the UID or GID of a process is impossible. Calls to chown will mostly fail. There's a workaround for these. I might be able to use seccomp filters. I haven't tried it yet, but it may help. So let's look at various ecosystems and their compatibility with Lxroot. Alpine, Arch, Void, Flatpak, and Aptors all work well inside of Lxroot. App image, you must convert it to an Aptor, but I might be able to improve this process. Ubuntu, Debian, and apt, they have poor compatibility due to friction with apt. However, those seccomp filters that I talked about, that might make apt start working inside of Lxroot. And then in terms of Fedora, Snap, and others, I haven't really tried them yet. Let's see, so make computing personal again. In the 1980s, each app came on a floppy disk. The user controlled the floppy disk, and thereby the user controlled their computer. Today, apps come from an app store or a package manager. Today, the App Store controls the apps, and thereby, in my opinion, the App Store controls the computer. Lxroot lets users control the environment in which an app store or package manager runs. Lxroot thereby restores the user's control over their computer. Lxroot makes computing personal again. So using Lxroot to choose which software I run and how and when I run that software reminds me of booting up floppy disks back in the 1980s. So platform diversity. Let's see, as an end user, I use Lxroot to run apps and development tools from multiple ecosystems on a single desktop computer or server, and to isolate and or integrate those apps and tools as I see fit. An app developer or publisher could use Lxroot to bundle an app or game with a custom runtime environment, test an app against a number of target environments, or build an app in a controlled and isolated environment. I mentioned that you could overlay multiple directories together to dynamically create a chroot environment, so let's look at that. The simplest way to use Lxroot is just with a single directory. That's what I've done so far in these examples. One directory holds all the files. Lxroot can make select subdirectories read-only. If you want to combine two directories together, I often use a read-only system directory and then a separate directory for mutable data. The mutable data would be the home and temp directories, and they get bind mounted into the system directory, and then you Lxroot into that. And the third option is to use a system directory plus an app directory and then also a mutable data directory. But these are just three ways you can do it. There are lots of other ways you could set up your bind mounts. And for additional flexibility, you can Lxroot into a read-only BTRFS snapshot. So you can take a time series snapshot of a system as you update it and then run things in past versions of that system. So Lxroot's command line interface, I don't have a lot of time, but I wanted to show it to you. This is basically it. The mode is one of read-only, read-write, or read-auto. I don't have time to explain read-auto, but it's not that complicated. And then these are all the other options. That's all you need to learn to learn how to use Lxroot to create virtual environments. But if that's too complicated, I've also written a helper script, VLAN, a virtual userland manager. VLAN is a convenience wrapper around Lxroot. VLAN automates common Lxroot usage patterns. VLAN is written in -shell. And VLAN can create Alpine, Arch, and Void userlands, install and build packages inside those userlands, and run programs inside those userlands. And I'm going to stop now or skip the rest, just skip through it because I'm running out of time. So I was going to show you how to run Arch and Chromium inside of VLAN. I think I lost my time due to all the switching of the slides. So in conclusion, Lxroot is a safe and lightweight alternative to chroot and or Docker. Lxroot allows non-root user to safely install and run apps from multiple ecosystems. And I will leave it there. There's the GitHub page with more information there. And thank you very much.
That was a whirlwind.